Hi guys, so I'm going to run through 10.4 with you. We are solving quadratic equations in factored form. So you will see a lot of what we did prior to this with a quadratic was in standard form. Ax squared plus bx plus c all on the same side. And today we're going to look at factored form. So that's going to look similar, but a is out there in the front. And then we have x minus r1 and x minus r2. So it looks similar to what we've just been working with two binomials. So hopefully this looks familiar. And then r1 and r2 are just a way of differentiating the different roots. So if we go back to our quadratic, because that's sort of what we're still dealing with, we have a parabola, off a little bit, but that's our vertex. Remember, our vertex is our center. That is sort of your starting point. And then you have these two pieces, and they have four different titles. They could be roots, which you'll see today. We also have looked at them as zeros. They might be called solutions. And we talked about the fact that because they're both on the x-axis, they are also x-intercepts. So given a graph, you have your roots where they touch the x-axis. They could be called zeros when we use the quadratic formula. Sometimes you'll just see them called solutions or x-intercepts. And remember, vertex is your starting point. All right, so basically you're going to be given a binomial today, and you are going to have to solve it. So to solve, set each binomial, and remember binomial is two terms, so x minus r1 to 0, and solve. I'm going to try to keep things very straightforward today. So, example 1, y equals x minus 2 and x plus 3 equals 0. So you want to basically say, okay, cross out this y squared. That would be if you were graphing it. When you're solving it, you want to set it equal to 0, and then you're going to solve for each one. Sorry, I meant to make that a 3. So you take each binomial and you set it to 0. Then you solve it. So this is plus 2, x equals 2, minus 3, x equals negative 3. So they'll each have two answers. Most of the time, if you have two binomials, you'll be left with two answers, two solutions, if you will. So let's try another one. X plus 1, x minus 3 equals 0. So again, two binomials, we're going to have two answers. X plus 1 equals 0, x minus 3 equals 0, subtract 1, x equals negative 1, x plus 3, x equals 3. So you'll also notice here they're opposite signs. Positive 3, answer is negative 3. Positive 1, answer is negative 1. Negative 3, answer is positive 3. So sort of the shortcut, once you get used to it, is whatever's in parentheses is going to be opposite signs. It gets a little trickier if there's something in front of the x. All right, so let's look at something that if you were to be given, say, one binomial and sort of one standalone variable. You do treat it somewhat similar. You're going to say this is set equal to 0 and this binomial is set equal to 0. One of them is already solved for you. And then here is your other answer. So don't think just because there's not two binomials like the last one, there's not two answers. Still two solutions. So if I looked at this one, x plus 5 equals 0, I'd be left with x equals 0. Sorry, I'm a lefty, my arm gets in the way. And then x plus 5 equals 0. Subtract 5, x equals -5. Good to go on that one. So, still 2 answers. So let's look at a third option. We have something that we saw, I believe, at 10.3, special cases. We have x plus 5 squared equals 0. So again, when it's squared, we're not just saying draw the exponent into there. It'd be x plus 5 plus x plus 5. Very similar to the top. So x plus 5 equals 0, x plus 5 equals 0, x equals -5, x equals -5. One solution there. You don't need both of them. So most of the time they're going to be 2 solutions, but in this case, because they're both the same answer, you can assume the quadratic touches the x-axis once, and that's going to be -5. So let's try another one. X minus 4 squared equals 0. Write it out, x minus 4 times x minus 4. So your answer is, remember, opposite signs, only write it once, x equals 4. So again, recap. Most of the time, 2 solutions when you have 2 binomials. If you don't have a second binomial, that x is just going to be equal to 0, so one of your answers will be 0. And when you have a squared, you're only going to write it once and you're going to have one solution. All right, let's look at example 4. So they've upped the ante a little bit. You are now, given 2x plus 1 times 3x minus 2 times x minus 1 equals 0. So now you have 3 binomials. Again, nothing too crazy is changing here, adding 1 binomial to it. So it's actually called a cubic function. And we talked about this before we left, how cubic means cubed, or the exponent would be 3. You have 3 binomials broken up there. So you treat it the same way. Now you're going to set every binomial equal to 0. You had to assume it was going to get a little bit harder. So here, subtract 1, 2x equals -1, divide by 2, x equals -1/2. So most of the time, if there's a number in front of here, you're going to wind up with a fraction. Same thing goes for the next one. You add 2, 3x equals 2, divide by 3, x equals 2/3. Number in front, wind up with a fraction. And the last one, simple because it does not have a number or a coefficient in front of x, so x equals 1. So this one has 1, 2, 3 solutions. And just for sake of kind of showing you what this looks like, 3 solutions means it hits the graph 3 times. So it could be starting out here, 1, 2, 3. 1 solution, 2 solution, 3 solutions. So let's try one more. X minus 3, x plus 6, 3x plus 2, all equal to 0. You're left with x equals 3. Again, just opposite signs. X equals -6. And this one you might have to write out. -2, 3x equals -2. x equals negative 2/3. Boom. 1, 2, 3. So 3 binomials, 3 solutions. 2 binomials, 2 solutions. 1 binomial, because it's squared, 1 solution. All right, that is 10.4 for you. I'm teaching this at 11:30. If you need extra help, feel free to email me if you have any questions.